Imagine venturing for beyond Mars, pushing the boundaries of human exploration into the vast, silent stretches of our solar system. How do we get there efficiently, when traditional rocket engines relying on huge amounts of fuel, making long journeys incredibly slow and incredibly expensive? Well, nuclear engines are essentially a game-changer for deep space missions, designed to provide spacecraft with much higher propulsion efficiency and speed compared to conventional chemical rockets. They enable us to travel farther and faster, making destinations like the outer planets and even interstellar space more reachable. The fundamental advantage of nuclear engines lies in their energy source. Unlike chemical rockets that burn fuel to create thrust, nuclear engines harness the immense power released from splitting atoms. This process, known as nuclear fission, generates incredible heat or electricity, which is then used to accelerate a propellant. This allows for a much greater exhaust velocity, meaning the expelled material leaves the engine at a higher speed, directly translating to more efficient thrust and less fuel mass needed for a given journey. There are two primary types of nuclear propulsion concepts. First, we have nuclear thermal propulsion, or NTP, where a nuclear reactor heats a liquid propellant, typically hydrogen, to thousands of degrees. This superheated gas then expands and shoots out of a nozzle, much like a conventional rocket, but with far greater force and efficiency due to the extreme temperatures. Second, there is nuclear electric propulsion, or NEP, which uses a nuclear reactor to generate electricity. This electricity powers an electric thruster, like an ion engine, that accelerates a small amount of propellant, such as xenon gas, to incredibly high speeds, creating a very gentle but continuous thrust over long periods. The specific impulse, which is a measure of engine efficiency, for nuclear thermal rockets can be about twice that of the best chemical rockets. This means for the same amount of fuel, an NTP engine can provide twice the thrust for the same amount of time, or produce the same thrust for twice as long. This remarkable efficiency means missions could be completed in a fraction of the time, dramatically reducing astronaut exposure to space radiation and making complex scientific endeavors in the outer solar system much more feasible. So, these incredible nuclear engines allow us to envision a future where human exploration of the outer planets, including missions to Jupiter's moons, or even beyond to the Kuiper Belt, becomes a realistic prospect. By harnessing atomic power, we unlock the potential for journeys that are not only faster and more efficient but also open up entirely new frontiers for discovery and our understanding of the universe.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.